All right, welcome back. We are continuing with atomic models and the periodic table. You will be using page 69 in your interactive notebook. You should have the questions that look like this. And watch this short video and we'll get started.
This metal detector is kicking.
Yeah, I borrowed it from my grandpa.
Sam, we got something.
Oh, great. Another tin can.
Wouldn't it be cool to find some silver coins or a gold crown?
Yeah. But you know, there are lots of other precious metals out there, too.
Like?
Check out the periodic table sometime. You'll find them all right there.
Periodic what?
Okay, so you know what elements are, right?
Elements. They're the basic substances on Earth. The ones that can't be broken down into simpler ones, right?
Exactly. Nature's tiny building blocks. Everything in the world's made from them. The periodic table is a chart that shows every single element scientists have discovered, including metals, nonmetals, gases, and even some elements scientists have created.
Whoa, there sure are a lot of metals.
Yup, metals make up almost 75% of the elements. Some are pretty common, like iron, copper, and gold, and others, like cerium and thulium, are really rare.
Wait a minute. AU is gold?
Crazy, huh? It's scientist shorthand. There's a symbol for every element name. AU's from aurum, which means gold in Latin. Turns out lots of the symbols on the chart are from Latin or Greek.
Hey, what do the numbers mean?
They're called atomic numbers. They tell how many protons are in the nucleus of each element's atoms.
So copper has 29 protons and gold has 79?
Exactly. Each element is different, but elements also share qualities.
Do metals?
Sure thing. All metals conduct heat and electricity. That helps metal detectors find them.
Wild.
And metals are alike in other ways, too. They're usually hard and shiny, and they can be melted and formed into different shapes. Think bridges, tools, car parts.
Yeah, and Zoe's jewelry. So, is that why metals are grouped together on the periodic chart?
Right. They're grouped together because they share lots of similar qualities. That way, scientists can get tons of info with a quick glance. In fact, the chart also uses a colored key to cue them into which elements are solids, liquids, or gases at room temperature. For instance, you can see that helium, like you'd use in a balloon, is a gas. Silver, like you'd find in a ring, is a solid. And mercury is a liquid at room temperature. Mercury is what you sometimes find in thermometers.
Sam, how come good old H2O's not on the liquid list? Isn't water an element?
Nope, it's a compound. That means it's made with more than one element. What do you think H2O stands for?
Water?
Well, two atoms of hydrogen and one atom of oxygen. Scientists use equations like this to show which elements are in each compound.
H2O. Got it, coach. There's so much I didn't know about the periodic table. How it shows the elements in an organized way and groups elements with similar qualities together. Makes it pretty easy for scientists to know which elements are metals and which ones are nonmetals, and which are solids, liquids, and gases. Scientists can check out an element's atomic number to see how many protons are in its atom's nucleus, and use the element symbols to show which elements are in a compound. Man, this periodic table helps scientists find out all the info they need in a flash.
You said it, pal. And speaking of finding,
Okay, big treasure, big treasure. Oh man.
So we can describe an atom structure by looking at the periodic table. So when we look at the periodic table, we have these little squares, and in that square you have a lot of information. The number at the top is called the atomic number. That's the number of protons and electrons if it's a neutral atom. I want you to be careful with that because in nature that's unusual to have just an atom that has the same number of electrons and protons. But if you're using a periodic table, then that is your assumption. So anytime it's a periodic table, the number of electrons and the number of protons are the same. So we can remember it with an acronym called APE, APE. Atomic number equals protons equals electrons. The second thing we're going to look at is the chemical symbol. It is always begun with a capital letter. If it's a single letter, then there's one capital letter. If there's more than one letter in the chemical symbol, the first one is capitalized. Anything after that is lowercase. The name of the element is also printed in the periodic table square for the periodic tables that you guys use. So here we have every atom with 8 protons is oxygen. So you have the atomic number and the chemical symbol so far. Make sure that you're always beginning those chemical symbols with a capital letter. If you do not, that is incorrect. You're wrong. Your answer will be marked wrong. That is non-negotiable. So the next thing we're looking at is the decimal that is at the bottom of the table. The decimal number is the average atomic mass of the atom. So in other words, is the number of protons plus the neutrons all together. Now we're going to always round this number before we use it. So 15.999, we round to 16, and we will use that number to calculate the number of neutrons. In this case, the number of neutrons and protons is the same, so 16 minus 8 is 8. So for any atom, to calculate the number of neutrons, we subtract the number of protons from the total atomic mass in order to get that number. So you must be able to round correctly in order to get that number. So let's practice. We have phosphorus. Phosphorus is number 15, has an atomic number of 30.9, which rounds to. Hopefully you got that. Then we're going to take that number and subtract 15, which leaves us with 16 neutrons. Hope you got that on your own. Didn't just wait for me to answer. Let's practice again with lithium. So we get atomic mass of 7, subtract 3, and we get 4 neutrons. Pretty simple. So when we look at models of atoms, we have to be a little more careful. And the periodic table is just an average. It's pretty set. It's easier to kind of just, you just kind of know. With the model, you have to actually look and count the parts individually. So for this one, we can determine the number of each of the subatomic particles in a model by simply counting the parts. In this model, there are 12 protons, 12 neutrons, and 12 electrons. This model, if you count the parts and fill it in on your sheet, hopefully you can identify which ones are the protons and which ones are the neutrons. And of course, we know the electrons are out there in the cloud. Once you have that information, identify the atom. So hopefully you got 7 protons, 7 neutrons, 7 electrons, and it is nitrogen. Because the number of electrons and neutrons can fluctuate, you must count for yourself if you're presented with the model. So this one has a positive charge because it has more protons than electrons. Remember, atoms can lose and gain electrons to and from other atoms. They also have different numbers of neutrons in nature, so all the neutrons, they don't stay consistent. So for this one, you should have gotten 11 protons, 12 neutrons, and 10 electrons. And the identity was sodium. So your assignment after doing this is a periodic table riddles activity. So you're going to use what you know about the periodic table so far to answer some elemental riddles. Shouldn't take you very long. When you're done, you can work on whatever you need to work on. Have a good day.